Our life.
All right, thank you. Well, welcome everyone to this webinar. We can call it webinar. The idea today is to show you a little bit about Moonbeam connected contracts, and I brought Jeremy today, who is part of the Moonbeam DevRel team, to sort of show you a little bit of a multi-chain dApp that he worked on, and he's written blog posts about connected contracts as well. So my name is Alberto. I am also from the DevRel team at Moonbeam. And yeah, let's get started. So what I am going to do is that I'm going to share my screen. And yeah, make sure that if you have any questions, click the Ask a Question button. I already see a couple of questions by Thomas. So I'll get to them as we start the presentation when I feel they're a little bit more relevant to the topic that we're being discussed. So yeah, like I mentioned before, today we're going to talk about Moonbeam and unlocking the true interoperability with connected contracts. So we have sort of been pitching the idea of connected contracts for a little while now, and we truly think that it will be part of the future of blockchain, right? Like I mentioned before, today I'm joined by Jeremy, and we're both from the developer relations team in Moonbeam. So let's first talk about why the future is multi-chain, or why we think that the future is multi-chain. And we actually saw a phenomenon happening probably 3 years ago, where there used to be only Ethereum and a few other blockchains out there. But as the time has gone by, we've seen more and more blockchains offering sort of similar services, right? And so as time goes on and the tech becomes more standard, we think that initially, there were only a few, but we will see more and more blockchains that are going to become more and more specialized, right? So I think we see something similar today where, if you want to find a very specific service, there's always an app for that, right, on the phone. So, and why we think it's going to happen in the blockchain world, right? So first, we're going to see an increasing number of usage, assets, and services on these different chains. And like I said before, this has become true in the past couple of years, and we think it's a trend that it's going to continue. And it's actually going to accelerate because of new frameworks like Substrate, which is what Moonbeam is built on. And we have other frameworks like the Cosmos SDK, which makes building a blockchain a very, very easy, right? Compared to what it was before, that you had to build basically the whole code from scratch. So we're going to see, for example, if you need a blockchain that is only specific for a very, very, very narrow sort of objective, you're going to be able to build your own blockchain somewhat easy, right? This goes hand in hand with the next idea, which is chain specialization. We actually see that in Polkadot right now and in Cosmos, where there are specific blockchains that do one thing very, very well and very, very optimized. And this also goes hand in hand, once again, which projects that will see blockchains as scale-out strategies, right? I think one of the more clear examples right now is we have blockchains that are very specific for gaming inside the Web3 world. And so we have seen this trend accelerating, and we see that we think that it's going to keep continue as we move forward, and the general tech becomes more and more standard. And so if we talk about multi-chain apps and approaches, we can basically divide them into two different sort of strategies, right? On one side, we have seen centralized deployments when you have sort of all the logic and all the contracts deployed to at one chain, and you ask the users, the community, the assets to migrate to that centralized chain, right? And then on the other side, we also see multi-instance deployments in which you grab the same code base and you deploy the exact same code base to multiple blockchains. But the main caveat of this is that each of the deployments have no clue that the other one exists, right? They're like isolated islands that have no clue that there's an other island with the same code base doing exactly the same thing. And so on the centralized deployment part, the main drawbacks are that you're asking users and assets to sort of bridge to your centralized chain, to your centralized deployment. And that could create definitely user experience problems and security. And you're only targeting a limited market that is willing to do those actions, right? While on the other instance, which is sort of just deploy everywhere, you're basically fragmenting your user base, you're fragmenting features, and you're fragmenting liquidity, right? Because now you have to have multiple instances. You have to basically manage multiple instances. If you're going to deploy a feature, you got to make sure that you deploy it to all the instances, and so on and so on. And so in all this context of connected contracts, why is Polkadot important and why Moonbeam has deployed to Polkadot? And so the main Polkadot idea is specialization and connectivity, right? There are many best blockchains out there. And this is basically goes hand in hand to what we discussed in the first slide. And so Polkadot provides a framework, which is called Substrate, that it makes basically a specialized purpose-built blockchains very easy to construct, to build. And so Moonbeam being one of them, and Moonbeam is specialized in providing a smart contract platform in which Ethereum compatibility features are key, basically. And so basically Polkadot provides an L0 protocol that it's able to secure these blockchains that connect to it, called parachains, or these specialized blockchains called parachains. And so it's able to provide security services around block finalization. But more importantly, it's also enables these blockchains to talk to each other in a native way. And this basically means that there's a greater ecosystem that consists of multiple specialized blockchains that can work together to sort of provide a broader service and more efficient service. Excuse me. And so it's really important to say that Polkadot is nothing without the parachains or these specialized blockchains, but these parachains are nothing without Polkadot. And so now let's talk about the idea of connected contracts, right? We first started about why we think the future is multi-chain, what is the role that Polkadot has in this multi-chain future, and now let's get to the connected contracts. The main idea of connected contracts, if we want to summarize it in a let's say a catchy catchphrase, it's reach any user, asset, or service through Moonbeam, right? So we think that the future is going to be multi-chain. We think Polkadot is going to be key in this multi-chain future, and Moonbeam can become sort of the hub for this interoperability interactions. So basically, the main idea is that you can use Moonbeam to interact with Ethereum, with Cosmos, with Avalanche, but also to connect to other parachains that will provide a specialized service for the entire ecosystem, right? We're not talking about a parachain that provides a very specialized service for Polkadot, but through Moonbeam, any other blockchain in the world can access these specialized service. And so Moonbeam can sort of act as a hub for all these interactions and cross connectivity. And so how Moonbeam supports connected contracts, and this can be divided sort of in three different action bullet points, but there probably can be many more, right? So Moonbeam can help you design smart contracts that access functionally across many different blockchains because we've integrated a lot of the hardware or infrastructure around cross-chain messaging. And we're going to discuss this a little bit later down the presentation. Also, Moonbeam provides the ideal developer environment because it provides full Ethereum compatibility support, tooling, and infrastructure, right? So when you build on Moonbeam, you'll have an Etherscan explorer called Moonscan. You'll have all the Oracle, all the indexing services like the graph. You'll have Gnosis Save, which is another requirement that a lot of the develop teams basically require or ask for. And third, last but not least, because Moonbeam is connected to Polkadot, you can securely scale your dapps through specialized resources that Polkadot ecosystem can provide. And this is, for example, one of the parachains that I like to highlight here is, for example, SideHeist, which is a prediction market. So they have built a parachain that its only purpose is to provide prediction markets that are very, very efficient. And so it is really cool that you have this basically functionality baked into the runtime. And if any blockchain project in the world wants to access their prediction market, they can use Moonbeam to sort of through cross-connected cross-chain messaging protocols get to Moonbeam and then use the native cross-chain messaging protocol of Polkadot to target these specialized resources. So the key innovation here that it had existed for a while, but has quickly developed into being a little bit more mainstream is general message passing. And the idea of general message passing is that different blockchains that are isolated can communicate with each other to sort of either pass tokens, which has been the primary use of this general message passing protocols for probably the past 3 years. But more importantly is to pass messages, right? And what it's passing messages is basically a smart contract on a blockchain A can say to a smart contract, another smart contract on blockchain B, hey, I want you to do this action, or I want you to do this particular thing, or I want you to communicate with this other thing somewhere else. And this, even though this existed for a while, we have seen a ton of new projects that it's basically a consequence of this movement towards a multi-chain future, coming up with their own solutions. And Moonbeam has basically the main ones deployed into Moonbeam, like we have Wormhole, Axelar, Layer 0, Hyperlane, Sigma, and many others that are coming. So this is a key innovation that, like I said before, has become mainstream in this probably last year, and we think that this trend is going to accelerate and continue. And because Moonbeam is connected to Polkadot, it can also benefit from Polkadot's general message passing system that it's called XCM. So we can divide the types of connected contracts, right? I mean, we think that there are two main models. In the future, there might be more, but we think that right now there can be two main types of connected contracts. And so the idea of one of them being hub spoke model, in which it's similar to the centralized deployment that we've shown before, but the idea here is that you have the complex logic focused onto a single blockchain like Moonbeam, and then you have simpler logic deployed to these other blockchains that can communicate with this, with these sort of more complex logic, right? So we'll actually see an example of a hub spoke model connected contract in a future slide. The other type of connected contracts that we can discuss is you can call it point-to-point model. This is the name that we sort of like thought of, but it's sort of like the idea being that one interaction on one blockchain can be routed through multiple blockchains into a destination chain, right? So you can have sort of like peer-to-peer interactions happening, but the idea is that a blockchain on A can route a message to B, C to get to D, right? And so in both of these, the main idea of both these type of models is that deployments are aware and they can communicate with each other, but it's just like the way that they communicate is basically the types of connected contracts approach. And to actually sort of lead by example, I think it might be the best phrase here. Let's go into some of the examples. But first, let me see if there's any relevant questions in the questions and answers section. So what solution products and services or industries does Moonbeam have to potential to disrupt? This is a great question by Thomas. And I think the main idea here is that Moonbeam can be positioned to sort of provide this cross-chain interoperability approach by being sort of like central in the Polkadot ecosystem, right? Being Ethereum compatible and having all of these general message passing protocols deployed to it, so that it can communicate with all the blockchains out there like Avalanche, Polygon, Ethereum, BSC, which they have their own communities, their own liquidity, their own projects, and so on. And so I think Moonbeam can be positioned, it's positioned really well to sort of be, you can call it like a middleman, like a gateway, but also the brain for example, hub and spoke models type of deployments. So how is Glimmer being used right now, and what concrete features you do envision for Glimmer? So the token Glimmer, you can see the foundation website page is basically the utility token of the Moonbeam ecosystem. It can be used for governance, for securing the network through staking, and also for payment of fees. So I mean, this is the sort of the typical uses of Glimmer right now, and we do envision sort of the similar trend. I think Boba Beam, which is an L2 that it's deployed on top of Moonbeam, also is accepting Glimmer as for fee payment tokens. So that's another use case right there. So let's get back to the the connected contracts examples. And the first one that I want to talk about is Lido. And Lido, it's known for liquid staking solutions. And through sort of a connected contracts approach in Moonbeam, they've been able to offer DOT and KSM liquid staking on Polkadot and Kusama. So let's, in very simple words, let's try to explain how this works. And so the idea is that a user using MetaMask, using Ledger, whatever wallet it's Ethereum compatible and compatible with Moonbeam, can interact with the Lido contracts into basically saying, hey, I want to stake my XC DOT, which is the version of DOT that exists on Moonbeam. I want to stake it, right? And so basically what the Lido contracts, what they do is that they provide a liquid derivative, which is called in this case, the ST dot, but they're going to interact with a series of smart contracts on Moonbeam that are able to communicate with Polkadot through XCM, which, if you recall, it is the cross-chain messaging system from Polkadot. And how this works is that basically Moonbeam will say, hey, Polkadot, I want you to grab these amount of dots and stake them to these validators that I've predefined before. And so it's really cool if you think about it, because all the complexity, it's hidden from the user. The user just signs a transaction in MetaMask like they do for any normal dApp interaction. But what is happening underneath, it's a series of very complex calls and interactions between two separate blockchains that result in a very seamless experience for the user of just basically staking tokens in a separate protocol. And this really shows how powerful the cross-connected contract approach can be. A second really cool example, and this is a very, very direct example of a hub-spoke model, is called Prime Protocol. The project is called Prime Protocol, and they want to offer a multi-chain prime brokerage services. So the way that I like to explain this example is by basically explaining at a very high level how it works and what's the main idea, even though they provide other things. But it's sort of like a multi-chain over-collateralized stablecoin. So let's say that you are on Ethereum and you want to mint this Prime Protocol stablecoin on Avalanche, right? What happens is that they have deployed, or they will deploy, their main contracts or the brain of the operation on Moonbeam, and will rely on message passing protocols like Axelar Layer 0 on communicating with other simpler deployments or simpler logics that are there just to sort of interact with the end user. One way that you can think about this is like, the bank and the ATMs, right, at the end. And so the idea is that the users, for example, on Ethereum, will deposit the collateral, let's say ETH on Ethereum, and they can say, I want to deposit my collateral in ETH, but I want to mint my stablecoin on Avalanche. And what's going to happen is that through general message passing protocols, these messages will communicate with these interactions will be sent to the brain of the operation in Moonbeam, and the brain of the operation, which are basically a set of smart contracts, will basically say, okay, this user, Alberto, deposits some collateral on Ethereum, but he wants to mint the stablecoin on Avalanche. So once again, through general message passing, it's going to communicate with the logic on Avalanche and get the stablecoin minted there. So the main benefit here being that you're, once again, simplifying the experience for the user. The user doesn't have to bridge multiple times, but just with one single action, they can actually get the result that they wanted on a separate chain. And everything is basically handled. The complex infrastructure is hidden from that end user facing a layer. Last but not least, we have the port of call. It's just a name for basically a way that Moonbeam can act as a point of transmission. And this is a little bit similar as a hub spoke model, but basically it could be generalized to any dApp. And so, using Axelar Layer 0, Hyperlane, Wormhole, or any other GMP protocol that you have that has deployed to Moonbeam, you can communicate multiple chains for different interactions. For example, you can have an ERC20 on Ethereum can be actually sent through Moonbeam to any other parachain in the ecosystem, right? For example, USDC and Ethereum can pass through Moonbeam and can be sent to Hydra X, which is an AMM. Well, they provide more services, but an AMM on Polkadot. Another example, which is really cool, and it is actually possible right now, is to bring DOT from the Polkadot blockchain to the Cosmos ecosystem, to Osmosis. And how this works is that basically you will bring your dots to Moonbeam and you will use Axelar general message passing to sort of bridge your dots to Cosmos and to Osmosis. And if you think about this is using 3 different messaging protocols to do this action, which is, I think it's like the first time that this has happened in the history of blockchains. You're using XCM to bring dots from Polkadot to Moonbeam. You're using Axelar general message passing protocol to route this dots through Axelar to Cosmos, and then you're using IBC, which is Cosmos internal general message passing to get those dots to the osmosis chain. So I mean, I think what's exciting about this is that the combinations and possibilities are basically endless, and which is really exciting for the multi-chain future. So just to summarize, and before we go to Jeremy's part on the demo, the benefits of connected contracts approach. First, it solves the fragmentation issue that it's inherent with multi-instance approaches. We saw before that, for example, SushiSwap that is deployed to multiple chains, but these deployments don't know each other. You have the liquidity fragmented, and with a connected contracts approach, you could actually have sort of these liquidity concentrated in a single chain, which increases the liquidity efficiency and avoids fragmentation. You can also use increased efficiency by using specialized chains or scale out strategies. This is related to, for example, the Psych example that I told you before, where you can use specialized parachains inside the Polkadot ecosystem to scale and to provide more efficient sort of services. And last but not least, you can improve the end user experience by hiding the complexity, the infrastructure complexity. As I've showed you before, liquid staking through Moonbeam and Lido, it's super simple. It's just signing one transaction on your wallet. Bridging DOT to osmosis, even though if you think about it, that you're actually moving in multiple steps, is very seamless. And we think that more and more solutions that will hide this infrastructure complexity will start showing up as this technology matures. So I think I've done a lot of talking, so I mean, hopefully I didn't bore you guys. But the next step will be I'm gonna stop screen sharing and give control over to Jeremy, which is gonna talk about a multi-chain dApp example that he deployed, and he's gonna walk us through it. So there you go, Jeremy.
Great, thanks, Alberto. Let me share my screen. Okay, yeah. So hello, everyone. I'm Jeremy. I'm on the DevRel team of Moonbase. And today we're going to be looking over how to start how to get started making front ends for connected contracts. So as Alberto mentioned, a typical single chain dApp will have a single ecosystem to worry about. One node to use the RPC with, one network. It's pretty streamlined. Multi-chain dApps, on the other hand, with cross-connected contracts, will have a few more moving parts that will make building these front ends a little bit different. As it currently stands, most dApps live on a single chain and are only aware of a single ecosystem. But with a multi-chain dApp, every contract can utilize the power of every blockchain. This allows liquidity to be moved, separated communities to join together, and make use of blockchain specialization. So let's take a rough overview of the differences between a single chain dApp and a multi-chain dApp. So this here is a simple graph of how the user experience will be in a typical single chain dApp. If you've ever used a dApp, you'll know that the user will have to connect to the site with what's probably going to be their MetaMask wallet, but some sites allow you to connect with others. This is either automatic or like you open the site and it prompts you to connect automatically, or it's what happens when you press a button in the top right corner, which replaces the traditional Web 2 login. And once you're connected to the site, the network that your wallet is connected to will either be the one correct network that the dApp is deployed in, or a wrong network. If it's the wrong network, the front end should ask you to switch to that network. Or if you're using MetaMask specifically, it could also give the option to add the network to your wallet. But once the user has connected to the website properly, the front end can then start presenting transactions for the user to send off to a node. And when that user signs that transaction and sends it to the node, the front end has to listen to updates on that transaction, which, all that data comes from the RPC node. When it fails or when it succeeds, the front end should update the user on the status of that transaction, so that they know whether or not what they were expecting to happen happened. Typically, what we get is a little toast notification, and if you're not familiar with that terminology, it's a little rectangle that pops up in one of your corners, usually top right, or I've also seen it in the bottom left, that isn't too intrusive. And that's it. That's like the basic structure workflow of a front end DApp. Did you want to add something up?
Yeah, so I mean, I think to summarize here, if you've ever used a single chain DApp that has deployed to multiple chains, right? Every front end that you're presenting, it's only aware of that chain that you're interacting with, instead of sort of being connected to multiple blockchains, even though they do have multiple blockchains listed. Once you select one blockchain, it's like you land in that little island, and that's it. Everything is isolated to that specific blockchain, right?
Absolutely, and you don't have to worry about the nodes or the transactions from any other blockchain. So, I mean, I'm not going to say Web3 stuff is easy, but it's easier than having multiple of everything, which is what we're going to go into next. So a multi-chain front end isn't much different from a single chain deployment, except since it's multi-chain, there are more options to manage at almost every step. So users can connect to multiple networks. There are multiple transactions. There are multiple contracts. So let's break it down a little. Like in a typical single chain deployment, a user can connect to the website, little button at the top right. But instead of expecting and checking for one single correct network, the front end will check against a collection of networks. So switching is a lot more important to this case, because there's multiple functionality on multiple chains. So instead of relying on MetaMask to do all the heavy lifting of prompting the user to switch to a single chain, you're going to have to create some sort of component that, one, lets the user know what the options are, and two, lets them switch to those options. So that's usually a drop-down component where you can click on it and select the network that you want to switch to, and then it'll switch to that network or it'll prompt MetaMask to switch to that network when you select it. But it could, in theory, also be a radio component, though drop-downs are usually what I've been seeing going on. Maybe one day GMP protocols will support every single chain out there, and this selection of networks can be obfuscated away, but that's in the future. For now, we'll need the dropdown. Next, after we connect and select our correct network, a transaction based off of which network you're on will be provided to the user to either to sign and send it off to the node. As a developer, you'll be responsible for handling these different providers, these different instances of the contracts, and potentially the different configurations of the transaction that you'll be sending off to your user to submit. But after the user signs that and sends it to the node, the front end has to update the user on the transaction status. And this is very changed from the single chain deployment, because before we would only focus on a single chain, so a single transaction. But now we have at least two sources to query. We have the origin chain and the destination chain. Some protocols like Axelar and Hyperlane will allow you to track the message as it progresses through the connected contract protocol. So that could aggregate to 3 transactions. You see the origin chain transaction, potentially the Axelar transaction, and the destination chain transaction. And so it's kind of hard to represent this relatively complex process using just a toast notification or using 3 toast notifications, since toast notifications are little one-time temporary notifications that are separated. It might be better to represent them using a card. And if you've ever used a bridging solution before, they'll show you all 3 steps on the screen. So you're not required to make an entire explorer, but it is good to bundle this information into one section. And during the implementation, a lot of these differences can be simplified down to simply creating a collection of different objects, like holding a dictionary of addresses, or holding a dictionary of providers, or holding a list of, say, URLs to RPC nodes. And while doable, setting that all up to be a bit of a hassle. So my recommendation, if you are using a DApp, my recommendation if you're using React is to use the DApp package for these front ends, because it has multi-chain support and already has React hooks for specifically Web3 actions. Of course, you're allowed to use any implementation that you want, and the advice in this this webinar will be very general for all types of implementations. But for now, let's demonstrate the DApp for a little bit, and we can explain a little about the protocol while we go along. This is
before you move forward. Can you go back one slide?
Absolutely.
So I think one important thing to point out here, and actually I just realized this, is that this particular DApp structure that you're showing, it's like a peer-to-peer, it's like a point-to-point interaction, but it's really like peer-to-peer, because you're talking about one origin chain and one destination chain. But actually, like you said in the middle step, and when you say bridge receives, you can actually include here multiple bridges receives and multiple chains in the middle, right? So that
Right.
middle step can stretch as far as your imagination can go, right?
Oh yes, absolutely. I mean, in the example that Alberto was talking about with bridging Dot to the Cosmos ecosystem, that's 3 chains, or 3 that's 3 messaging systems. So what is that, 4 different transactions that we have to manage, right? So as you get further and further with how connected you want to get, displaying this data and tracking this data will potentially get more difficult. But that's a fun problem to solve.
Yeah, and I think the main problem here,
yeah, go ahead.
I think the main problem here is sort of that not problem, but it looks like challenge is to sort of like this complexity will have to be handled by the developer, right? The idea is that the end user, and you're gonna see this with the DApp that Jeremy will be showing soon, is that the user will just see sort of like a simple interaction, a transaction that it's gonna sign, but the developer and infrastructure system needs to be sort of robust enough to hide all this from the end user, which is not technical, and make sure that everything is smooth and points you to sort of like an action being done on a destination chain. But that action can be as simple as just hopping from one chain to another, to hopping through multiple chains and multiple messaging protocols. But the user just really, at the end of the day, the user doesn't really have to know if it's a simple one or a complex one. They just want to interact with this chain and do this, right? And so that's the complexity, I think.
And potentially someday this can be all bundled into a package and modularized. So you can say an XCM message. So we will use the package to view and monitor an XCM message, or an Axelar message, or or any other type of message. But for now, I guess the developer will have to really do most of the heavy lifting. But the future is bright, so we'll have to see. So this is the URL for the demo. So screenshot it now if you want to take a look. Anyone can try. It's all on a testnet. So let's go look at it now. Okay. So here is a not exactly pretty front end, but it gets the job done. We have the connection in the top right, like typical dapps. We can read from multiple instances of a DApp because we're working on a peer-to-peer model. So there are contracts on multiple chains. So the data, while connected and can be sent and edited to each other to in a decentralized way between different blockchains. The data is still stored in a decentralized way. So every blockchain will have their own relevant data instead of it being a hub and spoke model where all of the data might be on one chain like Moonbeam. So in that instance, you would have to read data from different blockchains like this dropdown is doing here. We can switch our network. So for example, I wanted to switch to the Phantom testnet. There we go. We have all the different test nets that are available. And this can be here or it can be up there, but I just, it's up to your implementation. I will show you what all this DApp does is send a string from one chain to another and stores it. And we're not going to look into the nitty-gritty details of how to write the smart contract portion or how it works in great depth, since there are many different providers for connected contracts like Wormhole, Layer 0, Axelar, Hyperlane. Today we're using Axelar, but you can use today's front-end advice for any of these connected contract solutions. But just so that we're on the same page, I'm going to show you a little bit about the Axelar smart contract that's being used right now. So when we're sending a message from an origin chain to a destination chain, we create a payload in the form of bytes. What we do is we take the string and we encode it into a payload of bytes. And then we use the gateway contract, which is Axelar's method of sending and receiving data across chains to essentially send that payload to a destination. And then when you're receiving that data from Axelar, you take that payload, we decode it back into a string, and we store it on the contract. So very simple contract and a relatively simple system that would work as you would expect it to. So if we go back, let's try to take a look and try to get that to happen. So let's say some message, Moonbeam is cool. And let's send it to the Phantom testnet. Okay. A MetaMask should have a transaction. And here we're spending a little bit of our native currency to pay for the transaction on the destination chain so that it can happen automatically. Okay, let's confirm. And this will take a while, but as you can see, what I'm displaying here in grouped together is one transaction on the Moonbase Alpha side, which is the origin chain, a second transaction on the Axelar side, because that's the medium through which it's going through, and a final third transaction, which has limited data due to Axelar's SDK when this was built, but it'll also show when that has succeeded. Now, this will take a little while because we're going through 3 chains. So now if we have any questions, now would be a good time to ask.
There are no questions, but we can discuss some other things,
Sure.
right? So, for example, on the top right-hand corner, you see Moonbase Alpha. So, I mean, this means that the DApp is currently connected to Moonbase Alpha. But I mean, one of the cool things about this is that because it's a sort of connected contract approach, the user will only have to be connected on one sort of blockchain, right? Even though you're reading state from, like you said, the Axelar status, the Phantom testnet status, and so on and so on.
Absolutely.
And the other thing, though, is that I think in the future, right? I think one of the ideas is that, like you said, I mean, this is an Axelar specific sample, but this could be adapted to sort of multiple, general message passing protocols in the ecosystem. So I guess you can do from, to, and then you can have a third section called like through or something.
Yeah.
Right.
Well, for example, I think it was Prime Protocol that's planning on using multiple connected contract providers to validate and send messages across their protocol. So when you're creating your front end and when you're creating your system to make a cross-connected dApp, you might also opt to use multiple chains, because at the end of the day, not every connected contract provider will support every chain. So
yeah, and not only that, I think one idea could be to send the same message, even the same message through different GMP protocols, and then have a system on the other side of the chain which sort of like, if one was received first, it will execute that one and will ensure that the second one does not get executed, right? So that way you can have sort of like a fail-safe switch, or also sort of like, the one that is quicker at that particular moment in time can be executed. So, I mean, I think the beauty of it all is that, I think possibilities are endless. It's basically down to sort of what implementation is done by each developer and what strategy they want to use and why. So,
absolutely. Here we see that Moonbase Alpha had their transaction succeed. The Axelar one is still pending. Here's Axelar scan, which is much more pretty than my my implementation, but we're just going to use it now to see, yes, it is still pending, and eventually it will be executed. All of this data, it is being executed. It's being executed. So I'll come back and see if this updates. Yeah, and in the back end, in the implementation of the code, both of these, there we go. So now, well, I'll finish my thought. In implementing these, in implementing this, we are using the Axelar SDK. So both the pretty app here, the Explorer, and this here are using the same data. So you can make yours essentially just as pretty as the Axelar Explorer if you wanted to. But let's look to see if that worked. So we're sending it from Moonbase Alpha to Phantom testnet. See if the Phantom testnet. Yeah, and there we go. It is updated. So it read from the Phantom testnet smart contract. And just like that, you've done a cross-connected smart contract call, and that's it. It's not too different from a normal dApp. We just have some extra components when considering switching between chains.
And I think the architecture as well is different, right? So I mean,
absolutely.
Since from point zero, from the moment that you start building your dApp, you got to make sure that the architecture that you use and the way that you build it is sort of aware of that there's other deployments out there, and also you need to be mindful of how you're going to present all this information to the user. Like you said, this dApp it's mainly an example. It's not to be like a production app or anything, but it's to showcase sort of like how an interaction that goes through multiple chains can be shown to the user, and how you actually need to be actually aware of like all the little steps that are happening in the middle, right? And so that's I think that's the main point of all this. So.
Absolutely. Do you think we have time left to drill into the code a little bit, or should we end it here?
Well, I mean, if you want to highlight any particular part of the code, you can do it. I would suggest to sort of zoom in a little bit, and yeah, if you want to highlight anything, go ahead.
Sure. Well, we can go into it a little bit. So let's look at okay. So as I mentioned before, we used DApp in our implementation of this app, and the main reason that we did this was because when doing these transactions or reading from transactions or reading from or doing any Web3 interaction, it's very easy to switch between providers and switch between networks. So, for example, here I'm reading data from multiple chains, which is exactly what this is. Um, Instead of having to construct a new contract and do this whole process of switching manually with Ethers.js, I can just use this hook and specify which chain ID I'm on. So helpful tools like this is really simplifies the process. Another thing that I want to highlight is the potential complexity of monitoring these transactions. So, for example, if I use accelerar function, which is a hook that was written specifically for monitoring these solutions in UseDApp, which is technically available but not for production. What's happening here is we're sending a transaction, which is exactly what's happening here with the send from to. And instead of doing just monitoring just a single transaction, instead what's happening is that it uses a typical contract function. So it's sending the first origin chain function, but afterwards, it also uses the Axelar SDK to manage and update the state so that the front end can update it properly. And we can see this when using the Axelar SDK. So here we're interacting with a bunch of different states, and this was created to help manage the process. And I expect that you'll have to create your own management system based off of what route you take when creating your own DApp. So this is part of the heavy lifting that you might have to do when managing these transactions and when monitoring these transactions based off of your connected contract provider. Each one is different.
Yeah, and I think one important thing to highlight this as well is that all this tech is quite new, right? And as a general idea of connected contracts matures, this will also bring sort of new SDKs, new, let's say, primitives, right? Like a lot of the tooling will improve, and a lot of everything should be easier for developers to do right now. And think about the DeFi ecosystem in Ethereum in 2007 and how it is today. You have a bunch of like portfolio trackers and this and that, and so this is why we think like the also the future is multi-chain, because right now we're starting to see a trend and everything will become more simpler even for developers, right? The goal is to make it simpler for the end user, but also the idea is that as this technology matures, it will be more mainstream for developers to implement all this.
Absolutely. And this tooling, I imagine, will be very important as we see connected contracts grow, because I'm fairly certain that it will. And, in potential hackathons, if you decide to create such a tooling, it might be very helpful for future developers. So
definitely, and stay tuned, because we do have some exciting announcements around a hackathon and cross connected contracts, right? So I guess for now, Jeremy, you want to tell us about the blog posts that you've written related to all this connected contracts?
Absolutely, definitely. So a lot of this content is based off of a blog post that I've written and is now published to the Moonbeam website. So you can go to the blog section there to take a look. I've written multiple blogs on how to use Axelar, and there will be more that come soon for different connected contract protocols. The links are here on screen if you want to take a look. But as I said, they're on the Moonbeam website. if that's it, would you like to send us off?
Yeah, sure.
Alberto?
I'll wrap it up. Yeah. So, I mean, if you want to contact us, you have any cross-connected contract idea, you want to check out Moonbeam, feel free to reach out through our social channels. We have Twitter at Moonbeam Network, Telegram, Moonbeam_official, Discord, which is the Discord official link, which is discord.gg/Moonbeam. We're, very, very active in our community. If you have any project or, even it doesn't have to be, connected contracts, but if it is, it's even better. But you can reach out to us at the channels that I've mentioned before. Make sure that you also visit our website, which is moonbeam.network. And we're happy to hear you out and check how we can help you out build on Moonbeam. So thanks a lot for tuning in, and we'll wait for the next session.